So David Winkler is currently on the board, or the chair of the board of directors for the Diabetes Research Connection, which is one of the funders for this. He has been very active in diabetes research over his lifetime, and I'll let him explain why for that. He was a trustee with the UCSD Foundation. He envisioned the UCSD Pediatric Diabetes Research Center that is being developed. He's on the board of the Scripps-Whittier Diabetes Research or Institute. He's chaired the San Diego chapter of the American Diabetes Association and has been honored by the San Diego chapter of the Juvenile Diabetes Research Foundation. So this is somebody who is a true champion and has championed the causes of forwarding this research. And I'm going to let him tell you a little bit about some of the research that they are supporting. So Dr. David Winkler.
Good morning, everybody. It's great to be here. Thanks very much to Salk and to STEAM for putting this on. It's great that you all are interested in diabetes, and as you just learned, there's a big difference between type 1 and type 2, although they kind of end up with a lot of the same issues, the same complications, and dealing with high and low blood sugar rates. I was diagnosed in 1960 with type 1 diabetes at the age of 6. Several of my members of my family have the disease, and as a consequence, I decided at a young age to get involved. And that was as a kid, when I would literally tell people I came out of the Stone Age, because we had to take our needles and sharpen them on grinding stones. We had to boil those needles in syringes. We were injecting animal insulin, as was just alluded to. Insulin used to come from pigs and cows. Now it's being made synthetically, and it's much better. So that's a huge advance. We used to do urine tests. I would have my blood checked 4 times a year, and it was very difficult to manage the disease. I ended up in the hospital a number of times. I started to show the beginning signs of eye disease associated with diabetes. The reality is that diabetes can cause a lot of complications, ranging not only from eye disease, but to cardiovascular or heart disease. There are neurological problems where peripheral neuropathy can be a serious problem, and there are amputations that happen to people. The reality is there aren't too many people that have lived as long as I have with the disease. The Joslin Clinic in Boston said recently that 1 in 10,000 type 1 diabetics has lived with the disease for 60 years, which will be the case for me next January. So it's amazing that I've lived this long. But the good news is that people that are diagnosed today are doing much better, but still experiencing low blood sugars. 1 in 17 type 1 diabetics still dies from hypoglycemia, which is a statistic from the Juvenile Diabetes Research Foundation. It's remarkable to me that that's the case. And so for all the reasons of the complications and the challenges of living with the disease, although it's a whole lot better now than it used to be again, we started this organization, and we included 3 professors at UCSD and myself. Started it in 2012. We went online in 2014, and the goal of the Diabetes Research Connection is to fund early career scientists who have out-of-the-box ideas. So when you all end up going to undergraduate and then graduate school, and you're looking for funding to help cure or prevent type 1 diabetes or deal with its complications, you should come see us, because what we do is we look at very simplified grant applications. We send those applications to our 80-member scientific review committee, and I'm happy to say that our first speaker's lab is run by Mark Montminy. He's one of many scientists on our scientific review committee. There are several at UCSD and at La Jolla Institute for Allergy and Immunology. We have scientists from Yale, where you did some research, and our next, I don't know, well, Chris Dudley, also a Yale graduate, is proud to know that Kevin Harold there is on our scientific review committee. So there's a lot of participation by the best universities in the country, and we fund research all over the country, including here in San Diego, but as far away as Yale and Harvard and Stanford, a number of the best schools in the country, and we are making advances slowly but surely. We started online in 2014 to crowdfund like Kickstarter. I'm sure you're familiar with that. We have to date funded 22 projects as of the end of this year, and several of our projects have gotten follow-on grants. We provide up to $75,000 in funding, and 3 of our researchers to date, 2 of them in San Diego, and I'll talk about their projects in a minute, have gotten over $1 million from the NIH, the National Institutes of Health, and other private foundations to be able to continue their research once they were able to establish proof of principle, which is the first thing that you want to do in a laboratory, is to basically show that something works. And then you continue to follow on with that in order to try to develop a drug or a medical device or something that will help improve the state of care for a lot of diseases, including many of the ones that are here at Salk. So what I'm going to show you, assuming I can advance this slide, is what we've done. I really encourage you to check out our website. I think you will be impressed by the number of projects that we fund. This is our current opening page, and what we're able to, in fact, that's the study that's at Salk, the third one from the left, second to the right. We are funding these projects, and if you go to our website, you'll see the other 18 that we funded. So we constantly have new applications coming in, going through our 80-member scientific review committee. I wanted to talk to you quickly about 3 projects here in 2 in San Diego, 1 in San Francisco. All 3 of these have gotten follow-on funding, some as much as $1.4 million after our small grants of, in these cases, only $50,000. So the rate of return has been remarkable. This project, which is going on down the street at the J. Craig Venter Institute, involves the creation of a new beta cell. It's unbelievable science. In John Glass's lab there, who is a type 1 diabetic, they figured out how to create a new form of life. They took a bacteria, they took the DNA out of the bacteria, they designed a new set of base pairs in the DNA, over 1 million base pairs. They put it into a bacteria and created a new cell. Dr. Hayek, who heads the medical side of the Diabetes Research Connection, approached the Glass lab and said, how about if you make a beta cell that won't be attacked by the immune system? Because the problem in type 1 diabetes is that we actually attack our own cells. The theory is to create a cell that won't be attacked, but which will be glucose responsive and make insulin in response to that glucose. So it's an artificial beta cell. And these cells would be immune privileged, meaning they would not be attacked, but they would have a kill switch in case for some reason they got out of control. Right almost across the street at the Sanford Burnham Prebys Medical Institute, Joseph Lantzman is taking muscle cells in zebrafish, and now they've moved to all sort of fat cells and other types of cells to cause those cells to be glucose responsive and make insulin. So if they can figure out a way to take a type 1 diabetic's own cells, a different type of cell from a beta cell, and enable it to act like that part of the pancreas, that would be remarkable work. He got money from the NIH and from a private foundation, $1.4 million. This is happening right here in San Diego, across the street. So very cool research. And the last one I wanted to mention is Peter Thompson. We gave him $50,000. Another one of our donors just recently gave him another $70,000. He's going to be relocating soon, but he's taking his science with him. And what Peter has shown is a substance that may cause the cascade of the death of beta cells in a type 1 diabetic. So if that substance can be blocked, it's, in theory, you might be able to prevent the disease. Again, he's received lots of additional money, and so what we're trying to do is seed the pipeline, if you will. Our researchers then go to the Juvenile Diabetes Research Foundation, NIH, and others to get a lot more money to move their research down the line. One thing I wanted to tell you is about a very recent development in type 1 diabetes that is not a cure, but it's helping quite a bit. And I actually use these devices. I'm wearing them right now. This is an insulin pump on the right side. It's kind of a generic pump. It's not the one I use. And then on the left side is a continuous glucose meter. This continuous glucose meter checks my blood sugar every 5 minutes, 288 times a day. Remember, when I was a kid, it was 4 times a year. So there's been a huge advance in the testing of blood sugar. And this new device, which is in my pocket, and which, I think it's in my pocket, it better be in my pocket, talks to my cell phone. So this little beast that was biohacked by parents of several parents of type 1 diabetics up in the Bay Area, this little device enables the communication between the continuous glucose meter and the insulin pump, and it tells it how much insulin to give me. So it's kind of an artificial pancreas, but not really one, because it doesn't know when I'm going to eat. It doesn't know when I'm going to exercise, so I have to input that data. And the other thing that it tries to predict where my blood glucose is going, but it's not always very accurate. So it's not a cure, but it's a huge leap in the care of type 1 diabetics. So I will leave you with that. I encourage you to look at the handout that you have and check in our website if you have family members, you know anybody. If you have type 1 diabetes, please take a look at what we're doing, because it's pretty remarkable. Thanks.